In this video, we are going to talk about permutations and combinations as well as the fundamental counting principle. So as you can see, I already have some stuff written down. You can just pause the video and write down what you need to as we go along. So the fundamental counting principle is how we're going to start. It's a quick method to count the number of different ways to arrange items from different groups of objects. So if you've ever been to a restaurant and seen you can make 5,286 different drink orders from our menu, like at Sonic. They didn't actually sit down and write down all of those different drink orders. They used the fundamental counting principle. So it says and then an easier way to kind of look at it is if you have some event and it can occur in a certain number of ways, and then you have a second event which can occur in a different number of ways, the two events occur in m times n ways. And this doesn't just stop with two events, it can be extended to any number of events. So when we look at the word event, we need to think about an event as a decision that is made. So, in our first example, how many different meals, appetizer, entree, and dessert, can be created if you could choose from 6 appetizers, 12 entrees, and 5 desserts? So, if you're sitting down to your meal, the first thing you're going to pick is an appetizer, then an entree, then a dessert. So we have 3 events or decisions to make. So our first decision would be which appetizer. Our second decision would be which entree. And our third decision would be which dessert. So from this problem, if you look, how many appetizers do you have? 6. How many entrees? 12. And how many desserts? 5. Now, this says m times n ways, so we're going to multiply all of those. And when we do that math, we end up with 360 different meal combinations. In our next example, in 1966, license plates had 2 letters followed by 4 digits. How many different license plates are possible? Well, let's look at how many decisions we have to make. 2 letters followed by 4 digits. So 1, 2, 3, 4, 5, 6. 6 decisions. So how many are possible for the first one? The first 2 are going to be letters. There are 26 possible. Then the next 4 are going to be numbers. And there are 10 possible. So when we do that math, we get 6,760,000 different license plates. Now, how might this change if we can't repeat letters and digits? Okay, well, does that change the number of decisions I have? No, I still have 6 decisions to make. And I know that my first 2 are letters. Okay, so the first one is still 26, because there's 26 possibilities of letters. Now the second one, though, it's not going to be 26, because I can't repeat. So whatever letter I chose from this one is now off the table. So how many letters does that leave me? I've got 25 left. And now the digits, the numbers, the first one, there are 10 possibilities for. But then whatever one gets chosen here can't be repeated, so there's only 9 here. But whichever one got chosen here or here, those 2 are now off the table, so there's only 8 here. So how many are left for your last decision? Hopefully you know that there's going to be 7 there. So if I do this math, I now get 3,276,000 different license plates. So, as you can see, it's drastically different when you can and can't repeat. Okay, I think we've had enough examples of those, so let's move on to something else. Okay, factorial. Have you ever in any standardized test seen, sorry, I can't get my paper to be where I want it to be. Have you ever on a standardized test seen something that looks like this, a number with an exclamation point over after it? That means factorial. Factorial means that number times that number minus 1, times that number minus 2, times that number minus 3, and on and on and on until you get down to 3, 2, and 1. Something you do need to just memorize, though, is that by definition, 0 factorial is 1, which is just weird. It seems like it should be 0, but it's not. It's 1. So make sure you put that in your memory bank. So let's try one of these examples. Factorial means that number times 1 less, times 1 less, times 1 less, all the way down to 3, 2, 1. So 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we'll just put that in our calculator, multiply all that out, and we get 40,320. So factorial isn't something to be scared of. It's actually pretty quick. So 4 factorial, 4 times 3 times 2 times 1, put that in your calculator, and you get 24. So why did we need to talk about that? Well, we needed to talk about that because the next 2 things we're doing, permutations and combinations, they include factorials. So a permutation and a combination are very similar. You can see that their definitions actually are almost word for word. The main important thing is that a permutation tells you the number of ways n items can be arranged at a time when the order selected is important. So that is very important. So if you have a group ABC and it's different from CBA, and I'll explain that a little bit more on the next page. So this is the formula, and you will need to memorize this for your test. NPR, like the radio, and it's n factorial divided by n minus r factorial. So let's try this, 8p3. So that is going to be 8 factorial, because 8 came first, so it's the numerator, divided by, in the denominator, I'm going to subtract them. With the one on the left first, and then the one on the right. So, what does that mean? Well, 8 factorial we learned up here is 8 times 7 times 6, etc. Okay, now in the denominator, I'm going to have 8 minus 3 is going to be 5, so that's going to be 5 factorial. So 5 times 4 times 3 times 2 times 1. Now notice, are we a little repetitive here? 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. So instead of multiplying all that out, I can cross those off because anything divided by itself is 1. So these things are just going to give me 1. So really, my problem is now 8 times 7 times 6. And that is 336. Combination is similar, but on a combination the order is not important. And that changes the formula a little bit. Instead of just having n factorial over n minus r factorial, we've got this r factorial here. So this will change it. So on this one, if I have this problem, again, I'm going to have 8 factorial on the top, r factorial, so 3 factorial, and then n minus r. So I'm just going to go ahead and do that in my head. 8 minus 3 is 5 factorial. So if I write all this out, the numerator is still going to be exactly the same. The denominator, however, has changed. It's now 321 times 5 times 4 times 3 times 2 times 1. So I'm still going to cross off this stuff at the end. So now my fraction is 8 times 7 times 6 divided by 3 times 2 times 1. So we learned 8 times 7 times 6 was 336. 3 times 2 times 1 is 6. So now do we need to divide that to finish? Yes, we do. So 336 divided by 6 is 56. So as you can see, when the order is important, you're going to have a lot more than when the order is not important. Now, when might be the order important and when might the order not be important? Well, let's look at these two examples. So pause the video and write these down. So on this one, we have 20 people running in a 5K. How many ways can the 20 runners finish first, second, and third place with no ties allowed? Here, 20 people are running in a 5K race. The top 3 advance to the regionals. How many ways can the top 3 finish? Well, in this one, notice the first place guy gets first place, or girl. The second place person gets second place, and the third place person gets third place. So, is finishing first versus second versus third different? Yes. So, on this one, we are choosing 3 runners out of 20. And is the order important? Yes, it is important. Because first place is different than second place, correct? And on and on and on to third place. Because you're going to get like a medal or something. So the first place medal is going to be different than the third place medal. So when the order is important, this is a permutation. Let's look at this other one. On this one, we have 20 people running in a 5K race, so same thing. This time, though, the top 3 finishers advance to the regional finals. How many ways can the top 3 finish? Okay, so we are still choosing 3 runners out of 20. However, on this one, if you finish first, or if you finish second, or if you finish third, does anything different happen? No. They all go to the regional finals. So on this one, is the order important? No, it is not. It's not important because all 3 get the same treatment. They all advance to the regionals. So this is a combination. Okay, so permutation uses the letter P, and we need to figure out how many total do I have? So how many total runners do I have? 20. How many ways am I sorting them? I'm sorting them into 3 ways. So this means I'm going to have 20 factorial divided by, and this is the easier equation, so it's just in the denominator 20 minus 3, so 17 factorial. So that is going to equal all of this fun. Okay, I don't want to write out all those numbers. I don't know if you do or not, but notice this one starts at 17. So I'm going to start the denominator at 17 and just write a few, because as you can see, this 17, 16, 15 and all that other stuff is going to cancel with this one. So once I cancel that, I didn't need to write out all those numbers. You can if you want, that would be more precise, more power to you. This simplifies to 20 times 19 times 18. So if I do that in my calculator, I will get 6,840 different ways for first, second, and third places. Now over here on my combination uses a C. We still have our 20 runners, and we're still organizing them in 3 different ways. So this is going to be 20 factorial divided by, now remember this one is a little more challenging. It's got the 3 factorial times the 17 factorial. So in the numerator I've got 20, 19, 18, 17, 16, 15 again. And in the denominator I've got 3 times 2 times 1 times 17 times 16 times 15. So what cancels on this one? Well, still the 17, 16, 15 cancels. So now I've got 20 times 19 times 18 divided by 3 times 2 times 1. So that's going to give me 6,840 divided by 6. So this one I will have 1,140 different groups of 3 that go to regionals. Oops, sorry, that was off the page. There it is. Okay, so that was a lot of information. So let's break it down. So this is the last page, but it breaks it down. So when do you use which thing? Because most of your problems on your assignment are going to be word problems, and you're just going to have to know which one of those 3 things do you use. So how do we determine this? Well, when we use combinations is when the order does not matter. All of the chosen items get the same treatment. That's a combination. Permutations are when order does matter, and each item is treated differently, and you would use these formulas respectively. You use permutations and combinations when selecting, drawing, or arranging some or all items from a group of similar items. So these are all similar items. Now, when do you use the fundamental counting principle? Well, that's when individual decisions are made about more than one group of different items. So for permutations and combinations, they're going to be the same item being arranged, or the same group of runners being arranged. For fundamental counting principle, you're going to have different things being arranged. So, looking down here, I have 3 examples. I want you to figure out which one, so pause the video, I want you to read them and figure out which one would be fundamental counting principle, which one would be a permutation, and which one would be a combination. Okay, I hope that you actually took some time to do that, because that is going to be an incredibly useful skill in your homework. Without being able to figure out which one is which type, you might get easily frustrated. So if we look at this, how many different coffee drinks can be made from 5 different foam amounts, hot or cold, and 10 different flavorings? Well, it looks like there's different things. We've got foam amounts, hot or cold, and flavorings. So with 3 different groups of items, that tells me this is going to be a fundamental counting principle. So it looks like I have 3 decisions to make. My first decision is my foam amount. My second decision is if it's hot or cold. And my third decision is the flavorings. So on this one, I need to figure out how many foam amounts do I have. Then if it's hot or cold. And finally, which flavor do I want? And I'm only going to allow one flavor for this. So 5 times 2 times 10 is 100 different ways. Okay, these next two, a teacher divides the class into 8 groups. Each group submits a paper. The teacher will select 4 papers to display. How many ways can the 4 winning papers be drawn? This one, we've got 8 groups, 4 papers. All 4 papers are going to be displayed. So, is that anything different? Does being the first paper selected get you any advantage or anything different over being the 4th paper displayed? No, it doesn't. So this is a combination. Because the order does not matter. They all get the same treatment. So how many groups do I have? 8 groups. And how many winners do I have? 4. So that means it's going to be 8 factorial divided by r factorial, so 4 factorial, and then 8 minus 4 factorial. So we've got 8 times 7 times 6 times 5 times 4, you get the picture, divided by okay, so where's my canceling on here? 4, 3, 2, 1 and 4, 3, 2, 1. I'm running out of room. So I've got 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1. So that's going to give me 1,680 divided by 24. So once I divide that, I will get 70 different ways. Okay, this last one, winners drawn from 25 tickets sold on a raffle. The first wins $100, second wins blah, blah, blah. You can read that. So, does the order matter in here? Well, first place gets $100, third place only gets 10. So, is there a different treatment? Yes, there is a different treatment. So, since there's a different treatment, this is a permutation. So, we're going to use the letter P. How many tickets do I have? Total, 25. How many are going to win? Only 3. So 25 total and 3 are winners. Then we use our, what is this? Formula. So 25 factorial over 25 minus 3, so 22 factorial. So it's going to give me 25 times 24 times 23 times 22 times 21, etc., divided by 22 times 21, etc. So what cancels here? The 22 and on. So I'm going to have 25 times 24 times 23, which gives me 13,800 different ways for the winners to be drawn. Okay. If you have any questions, please let us know, and good luck on your assignment.